So this first topic we're going to talk about are writing real world solutions. So that's something that I want to make sure you guys can understand. So here we go. In this problem, it says there are 11 apples in a basket. 6 of these apples are green. The rest of them are red. And then we're talking about a ratio. So ratios are often something that's very misunderstood. So it's important that this terminology you get used to. So it says, what is the ratio of all apples in the baskets to red? So the way that that's said, you're going to go all apples to red. Now, where you see the word to, you're typically going to put a colon. So all apples, how many apples did we have altogether?
11.
So we had 11. How many were red?
5.
So that's how you write that. It's going to be 11 to 5, or if you want to write that as a fraction, what it ends up being is 11 over 5. Is that clear? So with ratios, it's how it's stated that you write it. So in the next one, it says, what is the ratio of green apples to red apples? So again, at the 2, you'll put the colon. And then it's green apples to red apples. We know there's 6 green apples and 5 red apples. And so that's the ratio. And we notice that these are improper. You're not going to want to change these to mixed numbers. If I had gone red apples to all apples, all it would do would be flipping the fraction. Does that make sense to everybody?
Yes.
Okay. So with ratios, just remember, ratios, the colon's there. The colon is like the divider, okay? And again, let me just tell you what this topic was, just so you guys can have it. The topic is writing ratios for real world situations. Okay? So when you can go find these topics and be able to go from there very quickly. Would you like me to give you another one? Or do you guys feel like you've got it?
It's pretty easy.
I've got one student. Okay. Yeah, I'll do another one. Okay, so here we go. So here's the other one. It says there are 6 red marbles and 9 blue marbles in a bag. Okay? A tells us what is the ratio of all marbles in the bag to blue marbles. So what do you think that would be? We've got to think about how many total marbles we have. So we had 6 red and 9 blue. So our total is 15, correct? So it's telling me I have 15 total marbles, but then it wants me to compare it to the blue marbles. So then I should go the colon, and then how many blue marbles do we have?
Nine.
You can write it on the chat if you'd like. Does that make sense, Jared? Okay. Okay, so let's do this other one and see. All right, so now it wants to know the ratio for blue marbles to red ones. So what do you think that would be? What do you think that would be, Jared? Here, I'll do the hard part. 6 to 9. All right, so it's blue to red. Oh, 9 to 6. Yes, that's correct. Cool. So you got it. Makes sense. Oh, that's someone else. Jared, do you get why it's 9 to 6 and not 6 to 9? Jared? Yeah, so because it's going blue first, you want to put in the number of blue, then the number of red. So, I mean, it's left to right, okay? So if it would have said red to blue, then we would have gone 6 to 9. If it would have said red to total, we would have gone 6 to 15. So it's just the two different things that it's asking for that it's going to be asking you to answer for. Does that make sense?
Yeah, it does.
All right, cool. It's so much easier if you guys talk. Yeah, so if you guys can speak, please speak. It makes it easier for me. Okay, let's go on to the next one. So this one was, so we're finding what the actual price is of the problem here. So it's saying Kevin bought a suit on sale for $208.80. The price was 64% less than the original price. Okay, what was the original price? Now this is interesting. So we're gonna say X is our original price. Okay. X is our original price. If it's 64% less, that's going to give us what the discount would be, right? So that's how much they took off of the price. It's not giving us what the how do I want to say it to you guys so it makes some sense? It isn't the price that's paid. Does that make sense what I'm saying? Okay. All right. So in this problem then, to be able to find out what the price is here, we have to be able to manipulate it, right? So how do I want to say it so you guys get it? So if 100% is what we're looking for, right? If 100% is what we're looking for, and we deduct 64%, what percent do we end up with? I might need a calculator for this one.
36.
We're going to end up with 36%. That's important that we all get that. So that is, since it's a 64% discount, what we're paying to the original cost is only 36% of the original cost. Is that clear to you all? So then when we go to multiply, we're going to take what we're actually paying for. 36% as a decimal is 0.36 times X is equal to our sales price that we paid. Right?
Yeah.
So 208.8 divided by 0.36. The original price was $580. So if you wanted to find out what the discount was, because there's two ways to do this problem, I'll get the same answer, but you'll see how I manipulate it differently. If I did it with the discount, let's see, how could I do it with the discount? I think it becomes more complicated. I don't want to show it to you guys that way. I think it'll confuse you. Because we don't know what the discount price is going to be, so we have to subtract. This is the way to do it. Okay? These word problems are actually pretty sweet. Now, whenever they do this to you, it's important though, 64% less than the original price, right? What they're telling us there is that's the amount of discount, okay? So we should be able to see, we can check it, and that's a good way to do it. We can check this by doing this. What's 580 times 0.64? It's 0.64. So 580 times 0.64 is 371.20 cents in terms of dollars. So now we want to see if we took that discount away from the original price, would that give us the $208.80? So 580 minus 371.20, what does that give us? Doesn't that give us 208.80? And so we know we have the right work. But see, because we have the original price now, we can look at the discount and see how much the discount is to be able to go check our work. We okay?
Yeah.
Okay. All right. Write a ratio as a fraction in simplest form with whole numbers in the numerator and denominator. So in this case, what they're asking for is fractions. So if we would have gone back to this first one, you see how I wrote it, as a fraction up here? We never want to change them to mixed numbers. I could have also done this one as 15 over 9 and 9 over 6. This here could have been reduced to 3 over 2 to get the ratio, right? For every 3 blue marbles, there's going to be 2 red marbles. So you can reduce, and I think this is what this is alluding to. So understanding how to write this as a fraction, 12 to 30 is going to be literally 12 over 30, and then we need to reduce that, right? So what goes into both? I believe 6 goes into both, so we're going to get 2 over 5, right? And these numbers, since they're both whole numbers, we're good to go. Make sense? All right. So real quick.
How'd you get 2 over 5?
Okay. I can show that. So if I have 12 over 30, correct?
Yeah.
The smallest number that goes into 12 is 2. So 2 times
6.
2 times 6. And the smallest number that goes into 30 is 2, right? Which is 2 times 15, right? So the 2's will cancel, correct?
Oh, and then he's okay, I get.
So then smallest number that goes into 6 is 3, so that's 3 times
3.
2. And this is 3 times 5, so I get 2 over 5.
Yeah. Okay.
Makes sense?
Yeah, I got it. Yeah.
Okay. All right, so let's have you guys do another one. What if I gave you 18 to 72? Why don't you try that?
One-fourth?
Okay, let's see what that is. So whenever I'm uncomfortable with numbers, when they're large numbers, typically what I end up doing is I end up working with smaller numbers. So the smallest number that I know goes into both is 2. So I'm going to go 2 times 9 and 2 times 36. Right? So that's going to give me 9 over 36. Here now I know 9 times 1 and 9 times 4. And so my answer should be 1/4. Make sense?
Yeah.
All right, so there's those ratios. All right. The cost for packing 4 padlocks is $17.60. We want to find the unit price. So when they talk about unit price, what's meant there is they're looking for the price of 1. Does that make sense?
Mm-hmm.
So when they're looking for the price of 1, we need to be able to say, okay, can we figure this out? So I'll set it up algebraically, and then I'm going to show you how I would normally do it as a person instead of being all mathematical, okay? So I'd say 4 times the price of whatever the thing that I'm buying is going to be equal to $17.60, correct? Because the total price for buying 4 of these padlocks is $17.60. So what I need to do is I need to divide both sides by 4, right? And that's going to give me 440, I believe. Is that right?
Yeah.
1760 divided by 4, 440. So I know that the unit price for the padlocks is $4.40. Does that make sense? Now, when I realistically look at this problem, the math is essentially the same, but all I ever think of is total price divided by number of items. So I don't ever think of it when I do it practically in my head like I do on the left. I think of it like I do on the right. So right off the bat, I would have gone, oh, it's 1760 divided by 4 things.
In what instance would you round to the nearest set?
Oh, okay. So let's say that it was slightly off. So let's say that I had 1764 divided by 2. That's not going to go in perfectly, correct?
Oh, okay.
So that right there would have been 4.4. And then 0.5. Or, I'm sorry, not point, there's no 0.5. 0.5, correct? But how many digits do we have in our currency? In terms of after the decimal?
2.
We have 2. So this is as far as we can go. So they're never going to charge you less than their price. So they're going to round that, what? That's going to go up. And so the unit price there would have been $4.41 per unit. Does that make sense?
Oh, okay, yeah.
That makes sense?
Yeah.
All right, cool. All right. All right, I do want to talk about some other things today, if at all possible with you guys. Something that I'm sure some of you are running into and starting to get a little bit confused about. And I think it's worthwhile to discuss are these multiple step fractional issues. So I'm just waiting for one to pull up. So if I gave you something like this, okay, just so you guys have it, this is solving a multi-step equation given in fractional form. Oops, spelled fraction wrong. All right, so what is the first step to solving this problem? What do you think?
Isolate the variable?
So we want to get the variable alone. Very good. But right now, since we're in a fraction form, we'll consider this top piece as the variable. Okay? So if that part that's in red is the variable, what do I need to get rid of that's with the variable?
Underneath?
Right, that -9. So what is the -9 doing to the red piece?
Subtracting from it.
It's what?
Subtracting?
No. What does this symbol mean?
Oh, dividing. Oh, okay, yeah.
Got it? So good.
Yeah.
So since it's dividing, what we need to do is we need to multiply by that -9 to both sides. So I'm going to multiply by -9. Right? When I multiply both sides by -9, again, this is my piece that I want to isolate. The 9s are going to go away, right? And so I'm going to end up with, oops, I'm going to end up with x plus 37 is equal to -6 times -9 is 54?
54.
54?
Yeah.
So now, this is the variable. Right? That's what I want to isolate for. And so when I want to isolate for that, what's happening to the variable x?
It's being added.
Yeah, 37 is being added to it. So how do we get rid of the 37? We have to subtract. So I'm going to go x plus 37 minus 37 is equal to 54 minus 37. So x is equal to, looks like 17. Is that right? Let me check. I never trust myself. Just like I tell my students, you guys should never trust me. I'm human, I make mistakes, and that is the answer. Would you like to try one?
Yeah.
Okay, let me give you guys one. All right, here we go. 3x minus 23 divided by 2 is equal to a negative 4. Go ahead and try that. Did anyone come up with something?
13.
13? All right, let's see.
5.
All right, so we have 13, we have 5. Anyone else? Are people still working? So again, I'll just highlight. So I really like to use color. I know, I'm sure probably when you guys were all younger and teachers would do this, you'd make fun of them, and now we're in college and I'm doing it and you're probably making fun of me. But it makes me realize what I'm trying to go after. So by me highlighting that piece, I know that's the thing I want to get alone first, right? And since that's the thing I want to get alone first, I need to realize what's happening to that red highlight. So what's happening to that red highlight is it's being divided by 2, right? So since it's being divided by 2, that tells me I need to multiply both sides by 2. Did it again. Right?
Yeah.
So the 2's on this side will cancel. Let me, and I'm going to get negative 8 on the other side. Again, this is what I want to get alone. So since it's subtracting 23, I'm going to need to add 23. That looks like 15. And then to get the x by itself there, right? This is what I want. What is the 3 doing to the x when they're next to each other like that? They are multiplying. And so the opposite of multiplication is?
Division.
It's division. And so x is equal to 5. Should we do another?
Yeah.
Yeah, I can. This is something it's starting to build, right? This is really starting to build, and if you can understand this, the jump to Math 70 won't be so bad. So here we go. 4 is equal to 3x plus 20 over 2. It doesn't matter what side it's on. Go ahead and try this. Did anyone get it?
-4.
-4.
I got -4 as well.
Okay. It should be a negative number. Now I'm going to show you some of the thinking that goes into solving this problem. Okay? Instead of doing it mathematically and all like, these are the steps, I'm going to use some reasoning. Okay? So check this out. The red highlighted piece represents a number, correct? That makes sense to everybody? The red piece is just a number? Okay. So,
Yes, that makes sense.
okay, good. So, what number divided by 2 is 4?
2. Number divided by 2 or 2.
So, if I go 2 divided by 2, what is that equal to?
What?
Because someone said 2, right? So what's 2 divided by 2?
1.
Is that 4?
No.
Nope,
Yeah.
that can't be it. So what number can I divide by 2 to equal 4?
8.
8. So what I now realize is the red piece is equal to 8. Right? So I can say 3x plus 20 is equal to 8. Okay? Now look at it this way. I'm attacking it differently this time. How much would I need to spend if I had $20 to only have $8 left?
16.
What's 20 minus 16?
12.
It'd be
12, sorry.
no worries. It'd be 12, right? So I know that highlighted circle needs to be. I did it again. I need to spend $12, right? 3 times what is going to get me that negative 12?
Four.
I know it's going to be a negative 4, right? So that's the answer that you had gotten. But here I'm thinking about it like common sense, right? Like, okay, what numbers can divide that way? If that makes you feel uncomfortable, let's follow the steps that we've done. So I'll do it that way so you can see. I had to multiply both sides by 2, correct?
Yeah.
So I get 3x plus 20 is equal to 8. Now I need to go 3x plus 20 minus 20 is equal to 8 minus 20. And that's important because sometimes people will go, some people will make the mistake and go 20 minus 8. The subtraction goes with the 20, so it's important that you write it in the right position. That's going to give me a negative 12. I have my 3x. Now I want to get x alone, so I need to divide both sides by 3, and that will yield that negative 4. But those are all of the steps in order to be able to do this problem. It's starting to make a little bit of sense?
Yeah.
Okay.
Yes, it's making sense. Thank you.
Uh-huh. You want me to do one more? Or you guys feel comfortable now?
One more, just so that way we're clear.
Okay.
Thank you.
Very cool. And then I want to do one more topic too. Just I think it's we're
Can you go
starting.
back? Can you scroll back up more? I didn't get a chance to copy all of it.
Yeah, no
Just
problem.
need like 30. Thank you.
Yeah, no problem. Higher than that?
That's fine.
Okay.
Or you can go back to the math problem. I finished copying.
Okay, cool. Here you go. You guys ready for me?
One second.
You guys ready?
Yeah.
Okay, so I got
-20.
-20, right?
Yeah.
So we're going to go -15 plus x is equal to a -35, right? Because I had to multiply by 5. And then adding 15 and adding 15, I get x is equal to a -20. Make sense?
Yeah.
And there, obviously, I didn't show all the steps, but I wanted to get you guys to see. Once you get comfortable with it, you start seeing the pattern, okay? One more topic I want to talk about, and then I want to give you guys a chance to ask questions on any topics that you might be struggling on, because I think it's important to let you ask some questions. Here's this one. It's solving a proportion of the form x plus a over b equal to c over d. Okay, so that's the topic. And here's an example. So 5 over 2 is equal to 3 over x minus 5. This is starting to get a little bit tricky, right? So when we have proportions like this, in order to be able to solve them, we need to do a thing called cross multiplication. Okay? So we are going to cross multiply So that means that I'm going to, and I'll do this way, these are going to multiply, and then these will multiply. Okay? So when I do that, I'm going to go 5 times the denominator, x minus 5, is equal to 2 times 3. Okay? So then cleaning that up, what I'm going to do is I'm going to go x times x minus 5 is equal to 6. And now what we need to do is do, from here, it's going to be distribution that I'm doing, right? So when I distribute here, I'm going to get 5 times x minus 5 times 5 is 25 is equal to 6. Agreed?
Mm-hmm.
Okay. Then the next step is I'm going to add 25 to both sides. So this is called, and I'm just writing down these rules so you guys know them. You won't be tested on this right now, but it's just good for you to know. It's the addition property of equality. Right? So that's going to give me 5x is equal to 31. And then I'm going to divide by 5. So that's going to be the division property. Again, of equality. And so x is equal to, you can either say 31 over 5 or 6 1/5. Did I break that down enough for you all?
Yeah.
All right. I would like you to try one, at least one. So let me give you one. Did everyone copy it down?
Yes.
All right, here we go. 8 over u plus 4, that's a u, is equal to 6 over 7. Go ahead and try that. Agreed?
Yes.
Okay, let me show you another example, and then we'll go from there. All right. Oops. Go ahead and try that one.
Sixteen over 3
Here, let me check.
Or 5 and 1
and
third.
1/3. Yeah.
Oh, so it's the exact same answer? Huh. You guys are right. Yeah. And that is 5 and 1/3. Okay. So does that make sense?
Yeah.
Yes.
Cool.
Yes, that makes plenty of sense. Thank you.
All right, good, good, good. Let's see. Let me find out. Let me see another one that people are kind of dealing with. Okay. I'll do this one and then I'll call it a day after this one, okay? You guys are all... Can you just call it a day?
One more.
All right, so here's the topic. Okay, so they're giving us 2 and 27 over 40, and what they want us to do with this is to convert it to a terminating decimal. Okay, so let's see. Is there any way that we can reduce 27 over 40?
Improper fraction.
Well, no, I'm just saying just the 27 over 40.
Oh.
Is there any way to reduce that?
So, well,
I feel like there is a way to reduce it.
No, there isn't.
Yeah, unfortunately, 27 is a prime number, and so we can't
Oh, okay.
reduce this. And so,
Okay, that makes sense. Thank you.
yeah, and so the way I would do this problem is you could make it a mixed number and be all complicated, but I don't want to do it that way. So I'm going to go 2 and then decimal, and then I'm going to do work on the side. So I'm going to go like this. Does 40 go into 27? The answer is no. So I got to put a 0. Oh, that's funny. I turned it into a circle. And then I got to add a 0 here. So does 40 go into 270? What do you guys think? How many times does 40 go into 270? I think it's 6, right?
Yeah.
So let's try 6 and see. 6 times 4 is 24, and then 6 times 0 is 0. I've got to subtract them, so there's a 30. Let's add a 0 and bring it down. How many times?
Professor, I can't see the screen anymore.
Is anyone else having that issue?
It kicked me off and it went back on. Oh, now I can see it.
Oh, okay.
I
Okay.
can see it now.
Okay, good. So how many times can 40 go into 300?
Seven?
7 times, right? So we had to bring down that other 0. And that's going to be 280. So when you subtract, that's a 20. We got to bring another 0 down. How many times does 40 go into 200? That's 5, right?
Yeah. What?
So 5 is going to give us 200, and our remainder is 0. So there's our terminating decimal. So the 2 is from here, and then the 27 over 40 is 0.675. Does that make sense?
Yeah. So you just leave the whole number then, right?
Yeah.
You're just focusing on the. Okay.
Yeah, I wouldn't want to mess with the. I wouldn't want to mess with the whole number and make it an improper that's all big, because you're going to end up with the 2 anyways, right?
Yeah.
So best not to mess with it. Here, let me give you guys one for you to try. See if you can give me what that decimal would be. Okay, you guys ready?
Yeah.
So what is that, 3?
Mm-hmm. 4.
How many times does 8 go into 60?
7.
And 8 goes into 40?
5.
Does that make sense?
Yeah.
Okay. Do you have any questions for me that you'd like me to go over?
No? I think we're good.
Okay. Well, if there's no questions by anybody, I will let you go. Please hop on Alex. If there's anyone who isn't on Alex right now, in terms of they didn't weren't able to extend their access or anything like that, please reach out to me so that we can see if we can figure out something so that I can help you. Because we still have time for people to get caught up if they've had issues with getting on Alex to get their work done. I want to be able to help you as much as I can. And we still have enough time to where if you have missed out on that, you can still get caught up and be successful, okay? So just please reach out to me so I can help you, okay? All right. Well, on that note then, I will stop recording. And